Before you watch this video, I want you to remind yourself of how to simplify fractions. Try to think of as much ways that you could do it before we continue. So go ahead, pause this video and give it a try. So, how'd you figure it out? Different people may have done it in different ways. Some of you may have found it by looking for the LCM. So you may have said a half plus a quarter. The LCM of 2 and 4 would be 4. So 2 into 4 goes 2 times, so you'd multiply the numerator by 2. And 4 into 4 goes 1 time, so you'd multiply that numerator by 1. And that would give you 3 over 4. Some of you may have also did it visually. So you may have thought about it and said, okay, I want to find a half of something, right? That's probably somewhere right here. And I want to add it to a quarter of that thing. So that means I'd split that thing into 4 parts. And the quarter would be right here. So if I have a quarter here and a half here, then overall I'd have 1, 2, 3 quarters. So that would be equal to 3 over 4. Now, what if I asked you to find x over 2 plus x over 4? What if I asked you to take it a little step further? How would you approach it? Could we do the same thing? Well, if you think about it, right? When we were finding the half and the quarter of something, we could say that that something is x. And if this is x, that means this area would be a half of x. This area would be a quarter of x. And if we put them together, then it would also be 3 quarters of x. So that would be 3 quarters of x. So since algebra represents numbers, we can add algebraic fractions the same way that we do with regular ones. The same ideas apply. We could find the LCM, or we could do it visually, or we could combine equivalent fractions and so on. Let's get some more practice with a few more examples. Let's see what it really looks like. So here are 2 fractions that I want to simplify. I'm going to start with 3y over 8. Let me write it out. Plus y over 6. So I have both these fractions. The denominators are a little larger than the ones before. So I'm going to try and find the LCM of both of these. So what would be the LCM of 8 and 6? 24. Yeah. So 8 can go into 24 and 6 can go into 4. 8 go 24, sorry. 6 go oh, why am I mixing it up? 8 goes into 24 3 times. So I'm going to multiply the numerator by 3. So 3 times 3y is 9y. And 6 goes into 24 4 times. And 4 times y would be 4y. So overall, my answer would be 9y plus 4y, which is 13y over 24. In our second example, we have 6 over 5p plus 1 over 3ap. So the question is, what 2 number can 5p and 3ap go into? What's their LCM? Well, if we look at it closer at the numbers, 5p and 3ap, right? 5 and 3 both can go into 15. So we know that in terms of constants, it would be 15. And p can go into ap. So that means AP would be the LCM of P and AP, since both of them can go into it. So 15AP is our LCM. So if we break it down, 5P into 15AP, let me just write that here. That would kind of look like 5P into 15AP. 5 into 15 goes 3. P into AP goes A. So I would be multiplying the numerator by 3A. And 3a times 6 is 18a. Next, 3ap into 15ap. Let me just write that down over here again. Basically, what I'm saying is 3 into 15 is 5. And ap into ap is 1. So this would be 5 times 1, which is just 5. So I'll be multiplying the numerator here by 5. So that would be 1 times 5, which is 5. So simplified, my answer is 18a plus 5 over 15ap.